so any questions y'all have? We have a couple things planned, but largely this is to try to get y'all ready. I've only got my camera on just for a little while before my computer freezes, but basically what I wanted to say is I am so ready for the exam. It's kind of like when you're going home, you're driving home somewhere and you're just like, I can't wait to be home. If they have the exam right now, I'd be willing to give it to my kids. So if that's where you're at, if that's where you feel, I feel you. I feel exactly the same way. All right, so with that said, I'm going to invite Ms. Brown to jump in anytime she wants. And with y'all, if y'all have any questions, feel free to use the chat bar, or you can unmute your mic and ask the question, because it's all about asking questions. So the stuff I have planned today is basically to talk about, make sure everybody knows what the exam is going to look like and how that's all going to work. So teachers in the group, if you will look, there are two things out there on Canvas. One of them is this FRQ, and I'll have the answers up on Canvas here by 4 o'clock or so, but also that AP Chemistry cheat sheet. And notice that there are 3 FRQs. If you have not used those with your kids yet, that would be a good thing for them to do over the next couple days. So. All right, you guys all know, or you should know by now, that for the AP Chemistry exam, they want you to log in 30 minutes before. So if you haven't looked at the time yet, it's 1 o'clock next Thursday. So they're going to want you to log in about 12:30. How will you get that? Well, your e-ticket will either be emailed to you, or you can just log on to AP Classroom. Now, I know that most of my kids are not getting emails. So what I just told them is don't worry about it. As long as you can log into AP Classroom, then it's okay. Your ticket will be there on exam day, all right? They're going to give you a question. You got 25 minutes to answer it, however you're going to answer it, and then you've got 5 minutes to upload. Now, lots of people are like saying, yeah, but what if I want to take 1 more minute? What if I want to work for 26 minutes? You basically have 30 minutes to answer the question and upload it. But they've warned us that they don't really expect anybody to finish any one of the questions. They're kind of long. So answer all that you can, but make sure you turn in your answer. If you wait too long and are like, oh, I just didn't leave enough time to upload, then you've ruined all that good work. So as soon as that 25-minute timer is up, you really need to be looking at it and going, I do need to finish this one sentence, but then you need to get on uploading that and moving on to question number 2. Don't try to squeeze yourself into 29 minutes and 30 seconds thinking that you can get the whole thing uploaded in 30 seconds. Then after you submit the first question, the second question will show up, and you'll have 15 minutes for that one, and then an additional 5 minutes, and then you're done. So instead of 3 hours, it's only going to be 45 minutes of your time. And just think how wonderful that's going to be when you can take a deep breath and go, whoo.
Danny, you know why we're so ready for this to be over?
What's that?
Because today was the day we were supposed to take the test.
That's true. Today is the day that we were supposed to take the test. You're right.
Oh, one other thing about when the timer, the timer will start at 30 minutes. Just make sure everybody realizes that when you get to 5 minutes, under 5 minutes, it turns red. So that'll be a good thing to make sure you're paying attention to.
Right. Right. I can already tell, by the way, that my computer is locking up a little bit and the camera is stuck on. So here in a minute, I may have to get out. So Lee, you may have to just fill for a minute. So just so you know, all you students that out there at this web address, there's a testing guide, which is going to give you a checklist that they would like you to complete, not to turn in, but so that it's there. There's a demo, which I'll show you here in a minute, but just realize there's lots of information out there for you to practice and be ready. Now, a lot of people are complaining. Teachers are complaining, students are complaining. And my attitude is, I'm not going to complain about something I can't control. So I can moan and complain all day long, but that's not the point. My point is I can only do my best. It's not because it's shorter that they're not going to hand out any 5s. It's not that if you don't finish the entire question, you can't earn a 5. They are confident that with these 2 questions, they can still figure out whether you make a 1, 2, 3, 4, or 5. So they're not graded on a curve. It's not going to be any harder or easier than in previous years. They have said that if you're doing college level work, if you're showing good chemistry knowledge on most of the points, so at least half the points, that you will earn a passing score on the AP exam. That part hasn't changed at all. So don't sweat it. This is almost better in that we don't have to have 3 hours. It's only 45 minutes. All right. Now, you get 3 choices of how you're going to enter your answers. So you're logged in. The test starts at 1 o'clock. You see your question. You can either open up Microsoft Word or a Google Doc and start typing out your answer. You can then take that answer and you can type it into a text box. I'm not sure if that's going to format correctly, so I've been telling my students probably option A is not the one for them. You can also do the very same thing. This would be option 2. You can open up Word or open up a Google Doc, type out your answer, and then just download it from Google Docs as a PDF or as a Word document, a doc, and then you can just upload it just like you would upload anything. That would be option 2. And then option 3 is you can take a picture of your handwritten work and then upload it a photo at a time. Now, it's going to be 5 photos maximum, so you can't write on any more than 5 pages for one question. But you know that, sorry, lost my train of thought. So it can't be more than 5 questions. You also you should know from your teachers that if you have an iPhone, they have to be set to take photos as a JPEG, not as a HEIC. So Apple got all fancy with their formats a couple of years ago, and you just need to talk to your teacher if you don't know how, or just Google how to make sure my iPhone is exporting to the right picture. Now, there is a hybrid between these 2 right here. There is a way that you can actually answer the question and get right in between those 2. So you're allowed to answer it on paper, take photos of it, and then move those photos over to your laptop, put all of those photos into a PDF, and submit that PDF. But you would do it under this format. It wouldn't be as pictures. So, for instance, Jillian, one of my students, said, I've been practicing taking photos and then using, I think she said, notes on her iPhone. It'll put all the pictures together into one PDF, and she can just submit it that way. But you wouldn't do it over here where you upload a photo at a time. You can have handwritten work, and it can be in one document for a question, but make sure you're picking that option 2 as far as you're submitting. Now, for any teachers out there, Monday when we had this conversation, that was not allowed, and it came out Monday night that it was. So that is the official response now from the head honcho. So they can have either digital ink or handwritten ink submitted as a PDF, but it needs to be as a uploaded attached file.
That's great news.
Right. So these are 5 things you can do before exam day, and this is straight from the College Board practice. Make sure you log into AP Classroom and that you know that you're registered and you can get in. You can check your tech. So make sure your phone's charged and all that kind of thing. And make sure you have everything laid out for the exam. So we're gonna, any notes you have and those kinds of things. So let me go back here real quick and just make sure everybody understands. For option 2 and option 3 here, you need to make sure that you have already prepped out a document if you're doing option 2. So open up a new document, put your Apple ID in there. Sorry, not Apple ID. Put your AP ID in there and put your name on there and go ahead and label it AP Chemistry Free Response number 1. And do the same thing for number 2. And if you're going to handwrite your answers, go ahead and get a piece of paper and write that stuff on top of it so that you're ready to go. If you don't know which one you're going to do, maybe you're going to wait and see, then maybe do both. Go ahead and set up that document and get the pieces of paper written out so that you're ready to go.
Danny, sorry to interrupt. You're not supposed to write your name. You're supposed to be your initials because the person grading your paper is not supposed to know who it is.
Okay.
So it has to be your initials and your AP number at the top of each page.
Okay. I will have to tell my kids that because I did not realize that. Okay, thank you.
Yeah, you're welcome.
That's because she's an AP reader, folks. She knows what she's talking about.
Well, sometimes.
Right. So a lot of people have been asking about things. What about this? What about that? So these are things that are not on the AP exam. You should not be seeing the words entropy or Gibbs free energy. You should not be seeing things like thermodynamically favorable. There shouldn't be any questions about voltage or the Nernst equation. You shouldn't be using the words galvanic, electrolytic, Faraday's, amps, or a salt bridge. All of those are considered things that aren't going to be on the AP exam. And then finally, there shouldn't be any pH or pKa, pKb, or anything like that. You might have to do a titration stoichiometry, but we're not going to be tearing apart titration curves or mentioning buffers. So those are things that aren't going to be on the AP exam. Lee, you got anything else you want to add about that?
No, I don't. I think you covered all of that. That's great.
Okay. So I am going to reboot my computer and see if this works any better. So if you want to talk to him a minute about anything, you can. Maybe pull up the cheat sheet that we gave them or something like that.
Yeah, that's what I was thinking. The cheat sheet would be a good thing to.
So if you walk them through that, I'm going to get out and get back in.
Okay. Okay, the cheat sheet that Matt sent out is really excellent. I actually had a meeting with my students earlier today, and I'm trying to pull it up. Sorry, let me. And really, I think the best. I'm not seeing where I'm. Hold on, just a second. I'm trying to present, and it's not showing that. There we go. Okay, so sorry about that. Well, what I talked about with my students, we kind of just talked through different aspects of it. And sorry, trying to get, there we go, finally. And what I suggested for them is that we kind of walk through everything that's on here to see if, you know, and I kind of guided them as to what, you know, what would we want to do, or is there anything we'd want to add or highlight? Okay, so I asked them the question, do you want to only use this, or are you used to the AP formula sheet? Okay, because this sheet has all the formulas you need on it. It's just a long document. So what we decided, and you know, I guess this is just a personal preference, is if they just needed a formula, they thought they might just go straight to the formula sheet and because they know where it is and they're very familiar with that, okay? But another student said, you know, I think I might go through, and if you'll notice on this, these are by topic, so it's, the formulas aren't going to necessarily be in the same order, but when there's a formula out. So maybe, you know, that might be something you'd want to highlight because, you know, those are fair game. There's also some, like I'm in the stoichiometry section, there's also these other formulas that, wow, now we have these right at our fingertips, and if we need to reference percent yield, no question, we remember exactly what it is. So it's right here. So my best suggestion for the formula for this cheat sheet is to make sure you've reviewed all of it and know where everything is. And, you know, if there's some things you want to highlight, I wouldn't, you know, write too much on it just because you don't want it to be messy or not be able to see where things are. But, you know, it reminds you, if you're asked for a conjugate acid-base pair, you can go straight to this section and go, okay, wait, the acid donates the H+. So I know what the acid, you know, just sometimes you get nervous and you might forget something that you have learned previously. And then here's, you know, the information about PES. So I just familiarize yourself with this cheat sheet. And, you know, I think this is going to be a huge resource, and decide, do I also want to have my formula sheet right there? Because a lot of my students said they did, and then they also wanted this there too for more specific information. All right, Danny, are you back?
I am. I'm back. Hooray.
All right,
my computer's really hot. I can actually like put an
Uh-oh.
egg on it and watch it cook. We'll see. So,
okay.
So I did want to take y'all through and show y'all just a couple other things. Let's see. Somebody had a question. Where in Canvas is the review sheet? So Dawn, it's in the review material, the 2020 review folder. And I think it's called the cheat sheet is in there. And I'll try to, yeah. Okay. And Matt's
go to unit 10, which is review, and then there'll be 3 individual review folders there, and it'll say review for 2020, and then that's all the documents that we've been putting up there just for this online test.
Right. So I did want to take everybody through just what does it look like when you go to put in your answers. So for right now, they have this web page up that's enter your Apple ID or your AP ID. Sorry. But, you know, obviously you should have done this by now, but if you haven't, there's no time like the present. For right now, they just want you to enter practice. But as soon as you do that, it's going to ask you to enter some certain information. So it wants you to do name, date of birth, 1997, because I'm really young. And my email address is captainawesome@gmail.com. And then Captain Awesome, whatever. And where are you testing from? It doesn't really matter. All of us are going to be at home in Alabama. And then you say yes. And then you just, oh, well, it wants an actual email. So, there we go. And then I hit agree and I hit continue and all that kind of thing. And it, okay, sorry. You would have thought I could enter a date. This would have been simple. But anyway, so once you do this, your exam will begin soon. But basically, it wants you to say, do you want option 1 or 2 or 3? And I've got most of my students are either writing out their answers and doing it by phone, or they're writing out their answer and attaching it as a file. I will tell you, reading through the question on just the phone could be kind of hairy. So if you have the ability to have both a phone and a computer, it may be helpful to actually have the question up on the computer. So log in on the computer and then use your phone to take pictures and transfer them to the computer so you can upload them. But obviously you're going to have to practice that. Don't let that be something that you do, you know, I'll just do it right before the test. So make sure that you know what that's like. Always plan for the worst. So it's gonna make me wait one more minute, and we don't have one more minute. So basically, you attach your answer and upload it. And if you haven't played with that, then let's try to make that happen. So go ahead and have fun with that. All right. I was asked to do a couple things before, so let's look at some of the things that you guys asked to see. And then we can go over the other stuff. So, all right. So I was asked to talk about kinetics and rate constants. So how are you going to find a value for K? Well, there's a couple different ways. You can either solve for a rate law, and if you want to, if you look back through the A+ College Ready Science Chemistry playlist on YouTube, then what you're going to see is we did a whole thing on kinetics and how to find K. But one of the ways to find K is write the rate law, and then you pick an experiment from a data table. You plug in the rate and the concentration of A and the concentration of B, and you can solve for K that way. That's probably one of the ways that they might have you do that. Notice that the way I'm typing here on this screen is exactly the way that AP has said to in that keyboard suggestion list, or like the chemistry keyboarding list. Basically, don't worry about making things superscripts and subscripts. You can type it in such a way that people can understand what you're doing. The other way is oftentimes the people will say, find K, and it's first order. So you know, if it's first order, that you can look over at that cheat sheet that Lee was just showing you. And on that cheat sheet, it tells you what the half-life is for a first order reaction. And on your normal equation sheet, there's a half-life for a normal equation. So if they told you the half-life was 10 minutes, then you would just plug in 10 minutes for the half-life, and you would find the value for K. So that seems fairly straightforward in what you're doing. I was also asked to touch on equilibrium with a common ion. So here's an equilibrium problem, and how would you do it? So calcium fluoride is going to split into calcium ions and fluoride ions. So if I was typing this out, normally we start with 0 of one ion and 0 of the other ion. And then for the change, we go that the calcium goes up by X, and the fluoride would go up by some factor 2X. And the 2 comes from the coefficient up above. So that at equilibrium, this would be, X, and this would be 2X. And we would just plug that into our KSP expression. And we would solve for the value of X, and that would give us molar solubility. So how are you supposed to solve a KSP problem when it's common ion? The exact same way. The difference here is instead of starting with 0 of calcium and 0 of fluoride, they might say, find the molar solubility when you already have some fluoride ion. So let's say that it says, what is the molar solubility of calcium fluoride in 1 or 0.1 molar fluoride ion? Well, you don't have any calcium, so that's still 0. But for the fluoride ion, this time we're not starting with 0, we're actually starting with 0.1 molar. So far, it looks exactly the same, except one was 0 and one was 0.1. this calcium would still go up by some factor x, and that fluoride would still go up by some factor 2x. And at the end of it, in equilibrium, the calcium ion would be x, and this thing would be 0.1 plus 2x. Still doesn't work. Hang on. All right. So how are we supposed to do it like this? Well, no one likes crazy math. And so what we say is 0.1 plus 2x is going to be pretty darn close, pretty, oops, can't type, darn close to 0.1. So instead of making your KSP expression equals x times 2x quantity squared, which is what we normally do up above in the red one, we'd make this one KSP is equal to x times 0.1 squared. So how are you supposed to do an equilibrium problem? Use an ice table. And how are you supposed to do it with a common ion? Put the common ion in there. And if you look back at the webinar that we did last week that Lee did, she went in and did a lot of these equilibrium problems, and they're not bad at all. All right. So does anybody else have any other questions before I jump into the FRQ I'd kind of made up for y'all? Let's see. All right, Sydney. No, cell potential will not be on the exam this year. That's a great question. Oh, Lee already got there. My bad. Hesham, let's see. So from what I read, and Lee, correct me, but no, you don't need to put your ID and initials on all sheets of paper, only on the first one, but it's not going to hurt it, right? So
actually, it should be on every piece of paper.
Okay. I thought it was just the first one, but yeah, so yes, put it on each one of those.
Yeah, if it's handwritten, yeah, if it's
right.
handwritten, it needs to be on every paper in case that you're uploading separate photos. But you know, on a Word document, yeah, right. The first page is good.
Okay. Brandon,
also,
is an iPad a good phone? Sorry, Lee. Is an iPad a good phone option to use? Yeah, if it takes good pictures, sure. If you're planning on writing on it with your finger or something, like drawing out, writing stuff, that just becomes an option of, can you get good work on there? Is it going to be big enough to get good work on there? But yeah, an iPad is just a big iPhone. Lee, what were you saying?
What I was going to say is, if you're going to use like a Word document or something like that, and you're preparing in advance, you know, remember you need 2 separate documents, right? So name one question 1 and name the other one question 2, because you don't want to answer question 2 at the bottom of like your previous question 1. So 2 separate documents if you're typing in responses.
That's a great point. Yeah. Karen, there has been a lot of debate about having the test open on 2 devices. And the last thing I saw was they would really prefer you not to do that. So I think if I wanted it open on a laptop so I could see it, I think I'd start out by loading it on the laptop and then moving the photos from my phone over to the laptop, because you can still upload the photos from your laptop with option 3, right? You would just have moved that picture or those pictures from your phone over to the laptop. That way you could see it the whole time. I know initially there was some thought about you could do both. Last thing I saw said that it probably wasn't a great idea.
Yeah, I don't think I would try that.
Right. Any other questions y'all have about content? Okay, so y'all, this test that we were supposed to take today was going to be hard. it was going to be 3 hours plus of your time. You would have had 60 multiple choice to go through with no calculator and 7 free responses. And it sucks that we don't get to do that, but not really, because now you get to show what you know in 45 minutes. And 45 minutes is doable. And there's no one taking up a bunch of your time during the day sitting in class or something. Y'all can sleep in a little bit, get your work done. And your test is not at 8 o'clock in the morning. Your test is at 1 o'clock in the afternoon, a teenager's dream for an AP exam, right? So this is entirely doable. I'm very excited for my kids as long as they take the time to show what they know. And I know that you can do the same thing. So I have pulled this thing for y'all to look at. It goes from A through F subpart III. That's way too long of a question for anybody to get through in 25 or 15 minutes, right? So what are you going to do? Instead of hitting the question and starting with A, you're going to take a minute. You're going to take a minute and go, what can I answer first? What can I know I'm good at? If you're writing it down, just leave some room. Or even if you answered things slightly out of order, as long as you label what you're doing, the reader can find it. So if you would do part A and then part C, that's okay if you then do part B after it, as long as you're labeling what part you're answering, right? So don't be afraid that you have to answer from A to whatever you can get done. Sometimes you can do this part down here at the bottom better than you could have done the part on top. And the idea is pick your strengths, pick the ones you know you can get right, and let's go ahead and answer those first. All right. So what I want you to do is I'm going to slowly scroll through the question for those of you who haven't seen it before. And I want you to give some thought as to what you would answer first. All right. So if I was a student and I was sitting in here and I felt really strong about calorimetry and delta H, I could very well start with part E. I could totally do part E first because I feel really strong about that. Does anybody see, and you can either type it in the box or unmute your mic, does anybody see one part of the question that they think would be easier to answer than other parts of the question? Like, what do you think the easiest part of that to answer is? Lee, do you have one area that you think would be easier than another since everybody's so chatty?
Well, I agree with William. I would start with A because molarity to me is an easy calculation.
Oh, sorry, William. I hadn't scrolled down. Sorry. That's what I get. All right. All right. So what is the molarity? I agree. The molarity is pretty easy. Okay. Does anybody see another one that they think would be very, very hard? Part D, subpart I, net ionic is tough sometimes. Very good. Yep. Haley, part C. Okay. Haley, do both of them look equally hard, or is there part I or subpart II? Or are you just part C in general? Okay. Right. So yeah, if you're not real comfortable with the whole KSP thing and equilibrium is not your strong point, just realize the entire test can't be about equilibrium. Now, what's the best way to make sure you miss a question? Don't answer it at all. But given the chance to come back to it, you can always take a stab for it and see what happens. All right, so let me flip over to the answers and we can kind of look at how you would approach each one. And if along the way y'all have questions, feel free to chat it up or unmute your mic and ask that question. So the molarity is simply put the number of grams divided by the molar mass, and that gives you the number of moles divided by the number of liters. Katie, what are you understanding? You said, are you understanding this correctly? All right. Well, Katie, if you get a chance to tell us, redefine your question for us so we have a little bit better understanding. I'll go back. If you look at that work, Miss Lee over there is probably just cringing looking at this work. This is me typing out work according to the keyboard guidelines, but notice how it's just all in one line. So I can make this a little bit better by doing things like wrapping this step in parentheses. That would make that a little bit better. The other thing I can do is not just write down a number here, but I can include units there. The molar mass is just of the barium, you're right, not of the barium sulfate. But it says, it tells you that many grams of barium ion, so that's why we're using just the molar mass of the barium. That's a good question. Oh, sorry, Katie. Yes, a question will be on more, because there's only 2 questions, so we would expect many, many topics. I like to think of it as a casserole. So it's not just meat or noodles or whatever, it's all over the place.
Yes, Mike.
Well, but yeah, so if they want to use asterisks for times, I think that even if the student writes out in such a way or types out in such a way, they get the message across. I think that even my work, as bad as it is, would be allowed. Now, the other way to do this work, if you wanted to be a little bit clearer, is you could type it out or write it out in such a way that you're doing real dimensional analysis. But you get to what is the molarity of the barium ion in the solution. And so that was the one that William thought was pretty easy, right? Now, notice that I'm not telling you how many points each one is worth, and we've done that on some other questions, because I don't know. So I'm hoping to show my work to get points, and I'm hoping to get the right answer to get points. That's the best you and I can hope for. And so show your work, include your units, and just do the best you can. The B part said to calculate the value of KSP. So the KSP expression is going to be just the barium ion times the sulfate ion. And however much barium we have, we also have the same amount of sulfate. Now notice, I'm not taking the time to write Ba2+ when I type it out and make that 2+ a superscript. An AP reader ought to be able to read this and go, okay, I kind of know what they're doing, right? But since I know the barium ion concentration is 2.09 times 10 to the -5th, then I know that's also the sulfate ion concentration. So to find the KSP, I really just need to square the 2.09 times 10 to the -5th. And that's how I would find the KSP value. Now, y'all keep in mind, even if you got the molarity wrong up here in A, so let's just say you made some little mistake. If you brought that number down and used it in part B, chances are you could still get the point in part B. So don't give up on it. A student makes a solution by combining some barium with some sulfate. After equilibrium is reached, would the student see a precipitate at the bottom of the solution? So this is the classic Q versus K think about. And if you were to look at that cheat sheet has down for you of if you compare K to Q, you know what's going to happen in a KSP problem. So this is a couple things going on. The amount of barium ion is the molarity times the number of, okay, I just realized I worked that particular thing wrong. Right.
That should be moles.
Should be moles. Thank you. Where were you an hour ago? Divided by, now how am I going to figure out my barium concentration when I know the number of moles? Well, you have to remember that you're adding 20 milliliters of one solution together with 40 milliliters of another solution. So what is my new concentration of barium going to be when I do all this math? It'd be the number of moles, 0.0002 moles, divided by 0.06 liters, because that is the number of the total volume of all the milliliters in solution. And I would have to do the same thing over here. To get the molarity. So the molarity here is going to be some number. And the number here is going to be some number.
Do you want the answer?
Sure, that'd be great.
The first one is, if I typed it in correctly, 0.0333.
Okay.
Oh, wait, nope, I'm off a decimal. I just realized it. Yeah, I need another 0.
Okay.
Sorry.
Gotcha. That's okay.
Yeah, 0.00333. Yeah. See, this is easy to do, right? Make a mistake.
Right.
I'm good at it.
Let me get it uploaded real quick.
Yeah, 0.00667.
Right. Nothing like changing things on the fly.
Yeah. Danny, for this, I mean, it's just another option. It's another way to think of it. My students kind of think of this as like I draw beakers on the board and we pour them together. So we're literally diluting both solutions. So it's that math we just did is really M1V1 equals M2V2.
Right, exactly.
So that's just another way to think of it.
Right. Can you run those numbers together for me?
Right. Yeah, that would be nice, wouldn't it?
Or Mike can do it.
He's probably already done it.
He's probably already done it.
2.22 times 10 to the negative fifth. Does that sound right? Yeah. Okay.
All right. So this would be our Q value. I'm going to come back and answer a couple questions. Sydney said, do you know if they have negative point grading? Or do you mean, okay, so if you mean that they're going to take away points, no, you only get points for showing good knowledge. So everybody starts at 0 and you earn points if you're going. The only time that you might lose a point is if you say something and then you say something else that makes it sound like you don't have a clue what you're talking about. In which case you kind of just never really earned the first point. If they want you to show a calculation, I would go ahead and write down a calculation, even if you're not sure about it. For part B, why did I square it? Because KSP is the concentration of barium times the concentration of sulfate. So if the barium is 2.09 times 10 to the negative fifth, then sulfate is also 2.09 times 10 to the negative fifth. Because for every one barium ion, I have the same number of sulfate ions. Ms. Pate, thank you for jumping in and helping out. All right, so once you have Q, then you have to compare Q to K. And so I always try to start with K. And so my K value was 4.37 times 10 to the negative 10th. My Q value is 2.22 times 10 to the negative 5th. Since K is less than Q, that means that we should see a precipitate form. So the arrow to the left tells us we shift to the left, and the arrow to the left tells us that a solid will form. All right, so then this becomes a Le Chatelier shift thing. So the initial solution is made at 25 degrees instead of 30 degrees. So in the beginning, they did it at 30 degrees. This is at 25 degrees. The KSP is 1.08 times 10 to the negative 10th. So is the dissolution of barium sulfate endothermic or exothermic? Well, really, it comes down to one of these two equations down here. Is it the one on the left in blue, where heat is a reactant? That would be an endothermic equation. Or is it the equation on the right, where heat is a product, and it would be exothermic? That's really all the question is saying. Those are your two choices. Heat is a reactant or a product. Well, what happens to K as the temperature goes down? Well, at 30 degrees, the K value was 4 times 10 to the negative 10th. At 25 degrees, a cooler temperature, it's only 1 times 10 to the negative 10th. So the value of K got smaller as the temperature got smaller. So if you take away something from a side, it shifts towards that same side. So if it's the blue equation and we take away heat by making it cooler, then less of the barium sulfate will dissolve. Some of those ions will shift to the left. Some of those ions will turn into solid. So if heat is a reactant and we remove it, then that should cause a shift to the left. If heat was a product and we cooled it down, remember, when you take something away from one side, it shifts toward that same side. So if it had been exothermic and it cooled down, then what we would have seen is more barium ions and sulfate ions. So we would have seen a K value larger than 4.37 times 10 to the negative 10th. This is just a kind of a Le Chatelier, which way does it shifts with temperature kind of a question. Now, if you saw that question and you had no idea, then I would say endothermic or exothermic, because you might get a point for knowing. So you can always guess. All right. Now, part D looks like it's part of the same question, but it really isn't. So the student decides to mix barium with sulfuric acid and make barium sulfate a precipitate and hydrogen gas. So write the net ionic. So the first equation I've written is just the regular equation. It said barium and sulfuric acid makes barium sulfate and hydrogen gas. Remember, to write a net ionic, you take any strong acids, sulfuric acid is one of those, and you split it into its ions, which I did down here. You take anything that's aqueous and you split them into their ions. And notice that there's nothing aqueous over here except for the sulfuric acid. And so the net ionic equation would actually be just the barium and hydrogen ion makes, and sulfate ion makes barium sulfate and hydrogen gas, right? So that would be the net ionic. Realize that you could include states of matter. So this could be solid and aqueous, but usually they don't require you to write states of matter.
Yeah.
But if you
don't worry about it.
Right. But whoever it was that was like net ionics bother me, I get you. Because when I had to write this one earlier, I was nervous about it. I should have been nervous about the problem above, but you know. So I would have landed on part II, and I probably would have done this one first, because this is a stoichiometry problem, and I know exactly how to do stoichiometry, although we'll see. So if you have 50 mils reacts directly with 1 gram, what's the molarity? Then you know what we always do. We change grams to moles, and then my mole to mole ratio is 1 mole of H2SO4 to 1 mole of barium. That's from the balanced equation. And I'm dividing it by the 50 milliliters to get the molarity. Now, I also worked it out a little bit better. Now, you tell me which one is easier for that reader to see. Miss Lee, when she reads my answer in June, is going to be very excited to see the second one and not so excited to see the first one, because when you show your work with units and you can see that stuff cancels, it's way better for the reader to know that you got what's going on. Right? And looks like I didn't write down an answer. So, oh, there it is. So the answer is 0.146 molar H2SO4. And that's just a simple stoichiometry problem.
I would type it in if you're typing and not handwriting, I would do it whichever way is easier for you.
Right. But I'd practice it whichever way you go. Make sure you practice it. I would probably have handwritten this, but trust me when I say, and my students can back me up, my handwriting is atrocious, and y'all can barely read my typing, much less my handwriting. So notice that then they run into a gas law problem. So they're basically saying, what is the volume of gas? So again, starting with that 1 gram of barium, I would change 1 gram to moles. And this time, instead of working it to the H2SO4, I'd work it to the hydrogen And that would give me the answer 0.00730. And then I can just take and plug that into PV equals nRT, because it tells me the pressure is 1 atmosphere. The volume is what I'm looking for. The moles came from my calculation for going from grams of barium to moles of hydrogen. The 0.08206 is a constant given to us on our sheet. And then you just have to remember that temperatures and gas laws have to be in Kelvin. And I get the answer 0.179 liters. Now, here's part that's not mathy at all. The rate can be studied by measuring the volume of hydrogen collected versus time. See where it says identify 3 separate changes? You don't have to explain yourself. It says identify. So let's see. I came up with heated up. Can any of y'all come up with some more ways that we could speed up this chemical reaction? What's another way to take a chemical reaction and make it go faster? Ooh, okay, catalyst. That sounds like a good idea. Increase surface area, another catalyst. Sydney, very good. You could increase concentration, increase pressure. So, Elise, maybe you could stir it, yeah. So, let's go back and look at a couple of y'all's things based on the chemical reaction. So, Christopher, your increased pressure here in this one particular instance wouldn't help because you're not increasing your reactants at all. Notice that the barium's a solid and the sulfuric acid is a solution. So if it had a gas in it, then yeah, increasing pressure would mean that's the same thing as increasing concentration. So it's a good idea. But you could heat it up. Let's see what else I came up with. You could add more of the chemical. So you could add more barium than 1 gram. You could also increase the concentration of acid. It doesn't have to be the 0.179. You could use 1 or 2 molar if you wanted to. But we know that more chemical makes for a faster reaction. There's the catalyst idea. And then grinding it up. And so who was it? Keandra, since you said increased surface area, you may want to be a little bit more exact in saying, what do you mean by that? Like beat it into a really thin sheet or grind it up into tiny particles so it's not one lump or something like that. Just something so that you not just name dropping, but are explaining. I don't know. Miss Lee, would they take stirring or would they just kind of shake their head?
I'm thinking not.
Okay.
I don't know. That's kind of that's a little iffy. I'm iffy on that. Sorry.
Right. No, that's fine. So just don't go with stirring. But it was a good guess, at least.
Yeah.
Right. The student is also required. So notice, we have covered a lot of topics so far, and that's what I want y'all to see. This test is going to be doable because you know something in every question. You know a lot in every single question. You just have to find the ones that are your strengths and make sure you answer those. Now, we're not doing with reaction. We're not worried about all the stuff before. They want you to calculate delta H. So delta H is measured in kilojoules per mole. So delta H is both a number and it's a sign. So don't forget that when you're calculating delta H, you have to think, okay, it's got a number, but I also need to give it a positive sign or a negative sign. So if it's warming up, if it's heating up, don't forget, you can go over to your cheat sheet, and on the cheat sheet, it tells you that exothermic things with a negative delta H, get warmer. So what is the sign of delta H going to be here? It's going to be negative something, all right? Now, here's the trick, and the reason why I included this question. We're going to use Q is equal to MCAT to do calorimetry. But what are we going to use for M, the mass? A lot of people are like, oh, do I include the barium? Do I not include the barium? How am I supposed to know what to do? Well, simply put, what got warmer? Sorry, I got a phone call. My bad. I even put it on Do Not Disturb. So what got warmer? Well, you dropped the piece of barium in the acid, and the whole lump of barium and acid got warmer. So what should you use the mass of? Just the barium, just the acid, or the two of them together? And the answer is we should use the mass of the two of them together, because what heated up? The barium and the acid. They were both together in the beaker. And then we multiply it by 4.18, because that's what we do. And we multiply it by the change in temperature. So how much did the temperature change? It changed 6 degrees. So when I did all that math, I got 2530 joules, and they want the answer in kilojoules. And then I divided it by the number of moles of barium. Well, why did I divide it by the moles of barium instead of by the moles of acid? Because it tells me it's 1 gram of barium with excess acid. So I know that my limiting reactant should be the barium, right? So I divide the kilojoules by the moles, and the answer ends up being 342. And we already decided it has to be negative, so I get negative 342 kilojoules per mole.
Will you explain how you got 100 grams of?
Oh, yes, I'm sorry. Yeah, sure. It tells you that the acid is 100 milliliters. And since it's 100 milliliters, you can't just automatically change that to 100 grams, but it tells you that the density is 100 grams per milliliter. I mean, sorry, 1 gram per milliliter. So if it's 100 milliliters and it's 1 gram per milliliter, that means the solution, the acid weighs 100 grams. That's a great thing. Right? Now, this next part down here has nothing to do with anything before, except we're just still talking about barium. So it talks about a photon of light, and they give you the frequency, and they ask you to calculate the energy. So what are you going to do? You're going to run over to your equation sheet, or you're going to run over to your cheat sheet, and you're going to find this equation, that E is equal to HV, or E is equal to H nu. H is a constant given to us, 6.626 times 10 to the negative 34th joule seconds, times the frequency is 1.26 times 10 to the 13th. And I get this many joules. Now, that is something that you guys did in just regular chemistry or regular PAP chemistry. And yet you can still get a point on this. So find the ones you can do and find that point. Now they might continue on and say, hey, by the way, can you tell me how many joules it would be if it was a mole's worth of photons? Well, this is for 1 photon. So if I wanted to find for a mole's worth of photons, I could just multiply it by Avogadro's number, and that would give me how many joules there were for a mole's worth of photons. Just something they might do that you might want to be on the lookout for. With the first ionization energy, so now we are down to periodic trends, and I can almost guarantee you there will be periodic trends because these are really easy to answer without doing a lot of calculations, right? Would the first ionization energy be greater than, less than, or the same as? And the answer here is find barium, find strontium, look at where they are on the periodic table. The first ionization would be less than, because barium has more occupied energy levels than strontium has. Please don't say that barium has more energy levels, because barium has all the energy levels. There just aren't electrons in them. Please don't say that strontium is on the 5th row and barium's on the 6th row without telling the reader what that means. Give them some kind of idea that you really understand that it has 6 occupied energy levels, or it has 6 principal energy levels with electrons in them or something. Since those valence electrons in barium are farther away, out in the 6th energy level, there's less pull on those electrons. So less pull means it will take less energy to rip away those electrons. Ms. Lee, what are your cringe things that you hear when you read people's responses for things like first ionization energy?
It's what you said. Students will say that strontium has 5 energy levels and barium has 6. The other thing is students, if you use the wrong vocabulary word, unfortunately, sometimes students will say orbitals when they mean energy levels, and that isn't okay.
Right. And if you look at the cheat sheet, there is a very concise explanation of exactly how to figure out each periodic trend. And you don't have to know fancy words like Zeph, and you don't have to think about shielding and stuff. It really always comes down to who has more layers of electrons. And then if they have the same number of layers of electrons, who has more protons pulling on those electrons. So just keep it simple. Try not to use fancy words and then end up tripping yourself up.
Can I make one point real quick?
Sure.
Like if students are looking at the cheat sheet, it has a great ionization energy explanation, but if you just copy that down and don't relate 5 and 6 to the specifics of the question that's asked, you will not get credit for a general answer. So use this as a guideline, but you must insert the information about the particular element.
Right, yeah, don't just say one has more occupied energy levels. You want to be specific. Like if you wanted to, you could even give like the noble gas configuration as a short piece of evidence that you know where those valence electrons are.
Yeah, you actually have to say one more energy level in words. Just, right. Yeah, if you don't, even if you have the electron configurations, you have to have more than that.
Katie, if you will email Matt, he can get it to you for the cheat sheet, but that cheat sheet was probably sent it out to your teacher, and you can also ask your teacher. It was just sent out this morning, I think.
Last night.
So ask your teacher for it and see if they can get it for you. Okay. All right, so the last thing is the student makes a claim, and in the practice questions that we've seen from the College Board, there are lots and lots of examples of the student claims. Do you agree or disagree? So they claim that the lattice energy of BaO is the same as the lattice energy of cesium oxide because they both have the same number of occupied energy levels. And if you look on the periodic table, they do live right next to each other. Do you agree or disagree with the student? Justify your answer based on Coulomb's law. So what are you going to do? That's right. You're going to go to your cheat sheet. You win the prize. So the cheat sheet is going to tell you exactly what Coulomb's law is. And there's even a section on that cheat sheet about lattice energy. So I answered disagree. Lattice energy is a function of charge and distance because that's what Coulomb's law is. They're both in the same row. So their distance from the nucleus is about the same. And Ba has a charge of +2. And oxygen has a charge of -2. So 2 times 2 is 4. Meanwhile, cesium has a charge of +1. and oxygen has a charge of -2, and 1 times 2 is 2. So 4 is bigger than 2, therefore the lattice energy is better. Miss Lee, can you think of a way that you would rather see that worded that would make you happier as a reader?
I like that last sentence, the charge comparison, and that needs to be, I think needs to be stated that there's a greater attraction between the barium ion and oxide ion.
Okay, so you would just say that because there's a bigger charge, there's a greater attraction.
Yeah,
Okay.
That's just the reason of the bigger lattice energy. Yeah.
Right. Okay, so I wrote this answer the way I thought I would have written it when I was 16. And so, because I wanted to end with y'all seeing when an AP reader looks at something like this, in the back of their mind, they're like, oh, they're so close. I think I might be able to give them a point. Where can I look, and are they really selling it, or are they just writing down stuff? So that going that little extra step to say a bigger charge means a greater force of attraction, which is really what Coulomb's law is describing, is the force of attraction between two things. That can make the reader go, oh yes, they do get the point. So just do a really good job of explaining yourself. Right? So y'all, this isn't going to be entirely, sorry, this is not going to be. This is going to be a hard test, but a doable test. So the night before, don't study all night the night before. You have a whole bunch of notes out in front of you. Get a good night's sleep. Get up and eat something. Maybe bring a beverage and a snack with you. You can wear whatever you want because no one's going to be taking any pictures of you. So it's the most comfortable AP exam you will ever take in your life. This is entirely doable, and I know y'all can do it. But just in case you need more help, next Wednesday at 2 o'clock, we will be doing this again, one last time, just in case you're not tired of hearing of from me and Miss Lee. So I know y'all can do this, and I really think this is going to be one of the easier tests in terms of the information is so much less than what we've had to do in previous years. So if y'all have any more questions, feel free to ask them. But that's all I've got, and I'm going to let Lee have the last word, even though I didn't tell her I was going to let her do that.
No, I think students have a great opportunity to do very well on this test. It's just a matter of managing your being nervous. So that's why practicing in advance and you're uploading and practicing typing answers, if that's what you want to do. Just being prepared in advance really is going to make it so much easier for y'all. But I think y'all are going to do great.
All right, y'all go and have a snack, and we'll see you later.